All right, so welcome to Chapter 3, Section 5, Graph a line using intercepts. So before we get started in the section, just going over the screen here. So the first thing that you should see is a due date for your assignment. I don't see that on the teacher preview, but you should always see when your assignment was due on your student screen. Attempts is the second thing you will see. I'm on attempt number 1 of unlimited attempts. I can come in here and do this as many times as I want. That's what unlimited attempts means. I am not limited to a certain number of tries. I can come back in as many times as I need to. Number of questions. So this one has 5 questions. For this section, it can be anywhere from 1 to 10 questions, depending on the section, how many were available. Grading policy is best score, so whichever attempt is your best score is the one that you get to keep. And partial credits enabled, so if you answer 1 of 5 questions, you get to keep the score on that one question instead of having to answer all 5. This down here just says, please remember, once you start your homework, you must finish it before you can work on anything else. So what that means is once I click start here, down in the bottom right corner, as a student, you won't see it on my screen, but as a student, you will see submit assignment. You always click a submit assignment when you're leaving this screen. Doesn't matter if you finished the assignment or not. You click submit assignment because that way, number 1, your teacher can see you've been working on it and what your grade is. Number 2, it affects the grade book so that you can actually see the difference it's making in the grade book to get a grade on that. And number 3, it'll stop the system from locking you out of all of your other assignments. The system automatically assumes if you just leave this screen without clicking at submit assignment that you want to leave this attempt open. So it just assumes that, and it will lock you out of everything else until you come back and finish this assignment. It assumes this is the next one that you want to start up on. So it's just kind of a system thing there for Alex. On the side here, we have explanation, example, and message center. So explanation will explain this problem to you. So it's telling me I'm going to lose my current question attempt because it's going to give me the answer to this question. It's not going to give me the answer and then let me come type it in. So, but it's a very neat resource because I can, sometimes you get stuck on a very particular question and you just want to see how would I solve that one. Well, you can see that and then you can come back in on another attempt to get the points for it. Example will just give you a general example of this one, and we talked about intercepts on the last one. So this one is now asking us about X and Y intercepts. So X-intercept is where we cross the X-axis. Y-intercept is where we cross the Y-axis. So remember, intercept is like catching the ball in football, and interception. Well, in math, it's where the axis catches the line, the axes. So it's just another term that we use in math here. So once we're happy with that example, we can close it. We can open it again for another example. It'll give you a new one each time. Or you can message your teacher here also. So this will attach the question to the message so that you can kind of directly tell your teacher where I'm having trouble. Okay. All right, so we're going to go on here and we're just going to look. It says find the X and the Y intercepts of the line below. Click on none if applicable. Well, it's not. This wouldn't apply, this none, because it does in fact cross the y-axis and the x-axis. We can very easily see that. So for the x-axis, the x-intercept, I'm going to go here to the x-axis and I'm going to, okay, it crosses at -4. So my x-intercept is -4. And my y-intercept, I'm going to go to the y-axis and just go up here and go, okay, it crosses at 4, so my y-intercept is 4. And that's it. We're just saying, where does it cross? That's the X and the Y-intercept. All right, so for this one, it says find the X-intercept and the Y-intercept. It's not giving us the graph this time, though. So what we want to do for the X-intercept, we want to take our equation and make Y 0. Because if Y is 0, if we think about our coordinate grid, that means I didn't go off of the Y-axis. I didn't go up or down. I'm right on the Y-axis. So if we make Y 0 and we solve it, so it's and solve, then we'll figure out what the Y-intercept is. And for the X-intercept, I said that funny. The Y-intercept, we're going to make X 0. Because again, I didn't go right or left. I'm right on top of the Y-axis. So that means that X has to be 0 in order for it to be on the y-axis. And then again, we're going to solve that. So let's go ahead and practice this and see what the heck I'm talking about here. So we have 7x minus 5, and it's y. Instead of y, I'm going to make that 0. And then I'm going to solve this. So I have 7x minus 5 times 0. Well, that would be minus 0. Do we really need to write minus 0? No, we do not. Because that doesn't change the problem at all. I can just kind of ignore that 0 that's being added or subtracted. So now I can deal with this 7x. This is 7 times x. So I'm going to divide by 7 to move it over. 7 divided by 7 is 1. So that's x equals 35 divided by 7 is 5. So my x-intercept is 5. Let's go over here and do my y-intercept. So I have 7 instead of x. I'm going to put 0. And y is going to go back. I'm not going to have 0 again for y. I'm only plugging in 0 for one or the other. So I'm not doing 0 for both at the same time. So now I have 0, and I don't need to write 0 minus, because if I had it like this, I would do 0 minus 5y. Well, I don't need the 0 there. I can just ignore it and write negative 5y equals 35. Just like I did with 7 up here, this is being multiplied. I can divide by negative 5. This does not mean minus 5. It means I'm multiplying by negative 5. So I have to divide by negative 5. Negative 5 divided by negative 5 cancels out. It becomes 1. Any number divided by itself is 1. 35 divided by negative 5 is negative 7. So we kind of ended up with the opposites there. Negative 7. All right. So we're going to click check. Yay. Let's keep on moving here. So we're going to do the same thing on this guy. And let's see, can I, so I don't have to rewrite that piece up there. Perfect. All right, so let's go to green. We're going to do the the x-intercept first. So I have 8x minus 5 times 0 equals 18. So 8x minus 0, I don't have to put that, I can just go to 18. And we have divided by 8, x equals 18 divided by 8. We do want to reduce this. It says write your answers as exact values. Do not write your answers as ordered pairs. So exact answers means no rounding. So if we do 18 divided by 8, and I'm not sure, let's see, I think I have my calculator open. Let's see, 18 divided by 8, I would get 2.25. And this might be okay. They actually might accept this, but you could also leave it as a fraction and just say divide by 2, like this. And I would get 9 over 4. So either one of these should be fine, honestly. They shouldn't be upset about either one of those answers. So let's go ahead and do the y. So we have 8 times 0, because I'm making x 0 this time, minus 5y equals 18. This gives me 0, so I just get to ignore it. Negative 5y equals 18. So I'm going to divide by negative 5 on both sides. And I have y equals, it's going to be negative, I know that. Let's see if I go back here, I'm going to go 18 divided by negative 5, and I get negative 3.6. So let's see if it lets me put in the decimals. I'm curious. So 2.25 and negative 3.6. Okay, so let me have those decimals. I know it will let me leave them as fractions though too. So this would be 18 over negative 5 like this, or I could have the decimal. The only time you want to be careful about the decimal is if it's a repeating or just a non-terminating decimal, and you would have to round it to type it in. It said exact answers. So I didn't have to do any rounding. The 18 divided by 5 is 3.6. I didn't round it to 3.6. So it stopped right there. It terminated for me. So just be careful about that, if you don't get a terminating decimal. Okay, so this one, we're just going to graph these 2 points. It says graph the line whose y-intercept is negative 8 and whose x-intercept is negative 5. So I'm just going to grab my pencil here, If my y-intercept is -8, I'm going to go to my y-axis and go down to -8 and place a point. And then my x-intercept is -5, so I'm going to go to my x-axis and go over to -5. And then I just connect these 2 points, and that is my line. So I'm just graphing those 2 points based on x and y intercepts. All right, one more of these guys. So the equation of a line is given below. Find the x-intercept and the y-intercept, and then use them to graph the line. So we're going to do the same thing we've been doing over here. So I'm going to erase this stuff. So that a little less erasing. I want green. All right, so we have 6x minus 3 times 0 equals 12. And again, I'm just using this equation they gave me here. I'm just making y 0. So 6x minus 3 times 0, that would be 0. So I'm just kind of ignore that guy. And I'm going to divide by 6 because I'm multiplying here. So division is my opposite, my inverse. 6 divided by 6 becomes 1. So 12 divided by 6 is 2. So I have my x-intercept is 2, and I can graph that already. I can go to my x-axis and go over to 2 and place my point. All right, let's do our y here. So we have 6 times 0 minus 3y equals 12. Well, this is going to give me 0, so I can ignore that. It goes away. And so negative 3y equals 12. Divide by -3, divide by -3. Negative 3 divided by -3 cancels out, becomes 1. 12 divided by -3 is -4. So I have -4. And I'm going to, oop, I already had my pencil tool. So I want to go to my y-axis and go down to 4. And then I want to connect those 2 points. All right, let's go ahead and check that guy. So that was section 5. Let's see, I don't know. Nope, we're not done with chapter 3 quite yet. So I will see you in section 6.